Hello and a very warm welcome to today's Dräger Safety Talk. Our main topic is about hydrogen and therefore we've invited our expert Oliver Bornhold.
Hi Annalisa.
Nice to have you here. Hydrogen is a very present topic. May you give us some examples about applications?
Yeah, so we are approached by many new customers that we didn't have on our radar. So we made some deep dives and seeing some new subsegments like in the mobility sector, for example, where we see new fuel cell applications where truck manufacturers or bus manufacturers converting their combustion engines to fuel cell applications, which gives then new safety challenges at the end. In the production of hydrogen, we see as well some new pilot projects currently. And then in the midstream, where the hydrogen needs to be stored and transported via pipelines that are already existing or maybe new builds. So there's, I think, from production over midstream, over the usage, a couple of new applications which are interesting for us.
As we can see, hydrogen can be used in many ways. As I know, there are different types of hydrogen available. What are the differences?
The differences are the colors. So they are, let's say, distinguished between colors. So we have, let's say, the traditional hydrogen, which is used since decades in the heavy industry. This is so-called gray hydrogen. So the majority of hydrogen nowadays is produced by fossil fuels, I would say, like gas. So there's a gas reformation process where the methane is then divided by hydrogen, and then we have carbon dioxide. And the carbon dioxide, and this is why it's gray, is released to the atmosphere. Then we have this so-called blue hydrogen, where same process, but the carbon dioxide is stored on long term. Could be an old gas field or could be somewhere else, where over a long term, which is then, let's say, neutral, climate neutral. Then we have another color, which is the turquoise hydrogen, where the carbon dioxide is not in a gaseous form, is then only carbon as in solid state material. And then finally, and this is going around the world more or less, is a so-called green hydrogen, where water is used as a basis material and via electrolysis, hydrogen and oxygen is produced. And herefore, we need a lot of electrical energy. And here, to call it green, renewable energies take into place. That could be wind, that could be water, that could be something else, geothermal energy. So everything that's renewable, it's for green hydrogen.
Nowadays there's a lot of reporting on hydrogen, especially on green hydrogen. What would you say? Is hydrogen rather a hype or a future-oriented solution?
It's no longer a hype. I think it's a hype maybe in the press, but hydrogen is used since decades. The green hydrogen is supported and sponsored, I would say, by the European Union, for example. It was triggered by the Paris Climate Agreement, and now a lot of countries around the world, really from Australia over China, North America as well, Chile, which is now one of the rising stars of the hydrogen economy, sponsors billions of dollars and euros to build up really a new sustainable energy source. So I don't think this is a hype. It's really a long-term new energy source that we are talking about.
Even though there are many advantages about hydrogen, lots of companies still not use hydrogen. Instead, they stick to fuel, fossil elements, for example, and old elements. Let's say it like this. What's our reasons for this?
It's the pure big amount of energy that is still needed in the industry and in consumption as well in our private sector. And I think on short notice, there's no way to transform in hydrogen economy that could cover these really big amount of energy that is used. But it's going a lot faster than a lot of people expected, that these green hydrogen projects will take a higher pace currently. And this is reflected by these large projects. But fossil fuels are still quite important for our economy and for our daily life.
Many people know that hydrogen is highly explosive. However, this is not the only challenge dealing with hydrogen. What are other challenges?
Hydrogen has in general some tricky physical properties compared maybe to other elements. And you've mentioned one. The flammability is another one. It's odorless, it's a lot lighter than air or other gases. And let's say the explosive limit is a lot lower than compared maybe to methane. And that brings some challenges with it itself, especially for some applications that we've touched already. And these challenges needs to be taken into consideration, besides the fact that hydrogen is not new, especially for traditional industries. But the newcomers, let's say, are a little bit, I would not say nervous, but let's see, at least aware that there's something to do in terms of risk mitigation.
So there are many challenges dealing with hydrogen. How should companies deal with these challenges, and what prevention measures could be implemented?
Sometimes they do not know. They're really asking, hey, I have here an application, for example, a fuel cell production. What should I do? I know there's hydrogen. Maybe I could have a release of hydrogen or a leak. How can I protect myself, my assets, my environment, and my people? And then we say we need to analyze the environment. That could start with the application itself and the risk involved in this application. So it means the probability of maybe a leakage, and then looking from, let's say, a small to big. So what kind of a building do you have? What kind of ventilation do you have? Where could possibly hydrogen, where I could possibly have hydrogen bubbles maybe on the ceiling, because hydrogen is lighter than air, and how will this interact maybe with other gases or your ventilation system internally. So all these things needs to be taken into consideration, and this is what our specialists in the field and our system center, this is their daily knowledge and their daily work, and this is what we see currently, a lot more and more new customers approaching us.
So there are many aspects to consider, but basically, how do a company know in time when hydrogen is leaking?
So normally you wouldn't hear that. So that means you cannot trust your ears, you cannot trust your nose because it's odorless, you cannot trust your eyes because the flame is invisible. So that means you have 100% rely on technology. And this is how we consult. So if there would be a high pressure leak, we would propose an ultrasonic gas sensor, which we have in our portfolio. If we may have a gas bubble on the ceiling, so there is a leakage, maybe there is no ultrasonic gas sensor, so where could this hydrogen appear? And so we consult them, bringing gas sensor, catalytic, electrochemical or whatever, close to this gas bubbles maybe on the ceiling. And other technologies as well. So it could be a flame detector, so because flames are also not visible, it doesn't mean always that you have an explosion. It could be a leak where you have an ignition and then you have a flame that could on long term cause other damages, but this needs to be seen also quite early, and technology can help you.
In general, there are many possibilities to detect hydrogen. In general, how sensitive are these early warning systems?
They could react within milliseconds. It depends a bit on the placement, on the technology itself. I would say in general early enough before it comes to an explosion, but it depends for sure on the proper consulting and where you place these sensors. It doesn't make sense if you have a wrong placed sensor which can react fast but cannot sniff hydrogen. So that means the combination is quite important, but in general fast enough to perform safety measures. It could be a cut-off, it could be forced ventilation or something else. So normally, and we know this since decades, our sensors are fast enough.
So the localization of the early warning systems plays a significant role, right?
Yeah, absolutely. And this is what we consult. So as I mentioned, we have to look into the whole environment, and then our specialist will look into the detail. It could be an indoor application where the sensors needs to be placed close to the ceiling, because hydrogen is a lot lighter than air and will go up. In combination maybe with the environment, ventilation, the heating system, you really have to check the whole environment, and based on that you have to propose maybe a set of sensors, not only one, and this is something that is normally managed and consulted in these projects.
Which devices do you offer to detect, for example, hydrogen?
Let's say the good part is that we have a quite complete portfolio for detecting hydrogen. So as I mentioned, early detection could be ultrasonic leak detector, so that we already know, hey, here's something going on, we could hear it. Then on top of that, that could be electrochemical sensors. Our Polytron family plays part here, the PAX 3000 in combination with that, and our mobile devices can protect the workers on site as well. Here we have our PAX solutions and the exam, maybe also for a clearance measurement. We talked about these applications already.
Okay. Well, you've explained a lot the advantages and also the challenges in terms of hydrogen. Finally, what would you say? Does the advantages outweigh the dangers?
Yes, a clear yes. Hydrogen is controllable. We know this from the heavy industries. The challenge is here with new applications. I expect also in the next 10 years that I hopefully get a fuel cell car at home. I have maybe storage at home. I can produce my own energy to do that. I believe, not I think, that it is controllable and it's safe, but it only matters about the safety measures that needs to be taken.
Thank you, Oliver, for this statement and also for the super interesting interview. And to you, many thanks for watching this video. As always, you will find every further information at our website. Since then, see you soon.